Hello everyone, I am Dr. Munish Kumar Bharadwaj from School of Engineering and Technology of IGNOU. Today I will discuss mechanical properties of aggregates. As you remember, in our last lecture, we discussed about flakiness index, elongation index, sieve analysis, then fineness modulus and grading of aggregates. Now in this lecture, I'll discuss with you the mechanical properties of aggregates, which will include aggregate crushing value, 10% fine value, then aggregate abrasion value, then aggregate impact value. So these four mechanical properties of aggregates I will discuss with you. First, let us take aggregate crushing value, ACV. The aggregate crushing value provides a relative measure of resistance to crushing under a gradually applied compressive load. What we do here, that we will take a sample, and on this sample we will apply a gradual compressive load. Then we will measure the resistance to crushing, and this resistance to crushing will give us the aggregate crushing value. Now, to achieve a good quality of concrete, aggregate possessing low aggregate crushing value should be preferred. So this is the importance of this particular test, that if we want to get the good quality of concrete, then aggregates having low crushing value should be taken for preparing the concrete. This test is more popular for representing the strength of the aggregate. So by this test, basically you can measure the strength of the aggregate. So how we determine? To determine the aggregate crushing value, a sample of aggregate passing through 12.5 mm sieve and retained on 10 mm sieve is taken. Means you will pass through the aggregate through the 12.5 mm sieve, and then this sample retained on 10 mm sieve. This will be taken for doing this aggregate crushing value test. So this sample of aggregate, which is in saturated surface dry condition, and as you know what is saturated surface dry condition, that you will first saturate the aggregate in water and you will take it out and the surface will be dried. So this sample of aggregate in saturated surface dry condition is filled in the cylindrical container in 3 layers by tamping each layer 25 times. You take the tamping rod and each layer will be tamped 25 times with the tamping rod in standard manner, and then it will be weighed. So let us take that the weight of this sample is A. This aggregate sample is placed in the test apparatus and is uniformly loaded through a plunger up to a total load of 40 tons in 10 minutes. This precaution we must follow, that we have to load this sample up to 40 tons in the test apparatus, and this 40 tons load is to be applied in a time span of 10 minutes basically. Here you see the aggregate crushing value test apparatus. Here you see that measuring cylinder. First, second is mold basically, and then third is plunger on the rightmost part. Then you see a rod, basically this is tamping rod, and now in that mold you see the aggregate sample and plunger put on that in the first picture you see that. Now this is the loading arrangement, that is the test apparatus. Here you put that mold and we apply the load, and as I told you, this sample will be loaded up to the 40 tons and within a time span of 10 minutes. So this is the rate of loading. So after applying this load, what will happen is this load will crush the sample. Now the load is removed, the aggregate is taken out, and now this aggregate will be sieved through 2.36 mm sieve size. So this sieve, through this sieve we will be sieving it. Now after sieving, the weight of the fraction passing through the 2.36 mm sieve will be taken, and let this weight is B. Means B is the weight which is the fraction passing through the 2.36 mm sieve. Now the aggregate crushing value will be calculated as B by A into 100. B here is the weight of aggregate passing through the 2.36 mm sieve after applying the load, and A is the weight of the prepared aggregate sample, total weight of the sample. So that way, from this calculation you will get the aggregate crushing value for the aggregate sample that we have taken for the test. So as per IS code 383/1970, aggregate crushing value should not be more than 45% for the concrete used for other than wearing surface. Means if you are not using the concrete for wearing surface, then permitted value of ACV can go up to 45%, but not more than that. But if we are using this for wearing surface, for this aggregate for wearing surface basically, then for that concrete the ACV or the aggregate crushing value should be limited to 30%. Means aggregate crushing value should not be more than 30% if the concrete is being used for wearing surfaces such as roads, runways and airfield pavements. So for that purpose ACV is limited up to 30%. So this is the use or the importance of aggregate crushing value test. Now let us move to the aggregate 10% fine value. This is another measurement. What we do here, that this is the another way of representing the strength of the aggregate. We first did the test of aggregate crushing value. Now here we will be measuring the strength of aggregate by this test, which is called aggregate 10% fine value. It is basically the load required for 10% fines. It is, we here are focusing to get that 10% fines because of that loading. Now it is more reliable than aggregate crushing value test for representing the strength of the concrete. Aggregate sample is prepared in the same manner as we did in case of aggregate crushing value test. The prepared sample, let this weight of the sample is A, is placed in the test apparatus and the load is applied uniformly through a plunger at a uniform rate so as to cause total penetration in 10 minutes as mentioned here. In case of aggregate crushing value, the rate of loading was important. Here you see, here this penetration is defined or prescribed, and that is to be done in 10 minutes again as we did the loading in 10 minutes in aggregate crushing value. But here penetration is specified. What is this penetration? 15 mm for rounded and partially rounded aggregates. In 10 minutes, 15 mm penetration for rounded or partially rounded aggregates. If we talk about normal crust aggregates, then this penetration is 20 mm. And if we talk about honeycomb aggregates, for example, expanded shale and the slag, this penetration is 24 mm. So for different type of aggregates, this penetration limit is defined, and that has to be within a time span of 10 minutes. After achieving the desired penetration, the load is removed. Now aggregate is taken out from the mold and it is then sieved through 2.36 mm sieve. The weight of the sample or the fraction passing through 2.36 mm sieve is taken. Let this weight is B. The load applied should be such that the percentage fines. How we calculate this percentage fines? That B divided by A into 100. And you know that B is the fraction passing through the 2.36 mm sieve and A is our weight of the sample. So this percentage of fines be in the range of 7.5 to 12.5 percentage. That this percentage of fine should be within this range, 7.5 to 12.5%. This calculation that we have done, B by A into 100. So this result should be within this range. Otherwise, the test is repeated with another load. If it is not so, then we will repeat the test with another load. Now 2 such tests are conducted and the load required for 10% fines is obtained by this formula. This 10% fine value TPFV will be equal to 14 into X divided by Y plus 4. What is X and Y? Let us see here. X is load in tons causing 7.5 to 12.5% fines, and Y is the mean percentage fines from 2 tests at X ton of load. Means if we are taking the X ton of load, then and we are performing 2 tests to get that percentage fines. So average of or the mean of the 2 tests will be taken, means we will be adding that result of the 2 tests divided by 2. That will be the mean percentage fines from the 2 tests at X ton of load, and that is the value of Y. So using this value of X and Y, we can calculate the 10% fine value from this formula. Now let us move to the next test on aggregate, which is the aggregate abrasion value. The resistance of aggregate to wear is known as the hardness of aggregate. Means if you want to measure the hardness of the aggregate, then this hardness of aggregate will be measured in terms of the resistance of aggregate to wear. This property is particularly more important for the concrete used for wearing surfaces such as roads, runways, etc. So this is the importance. That what is the importance of this abrasion value? That way it gives us the information basically that concrete which is being used for wearing surfaces, for that this information is important. It is measured in terms of aggregate abrasion value and is determined by 2 different tests you can do. One is Devil abrasion test machine and another one is Los Angeles abrasion test machine. So this way you can do this test by 2 different procedures. Los Angeles abrasion test machine is more commonly used as it gives better representation of hardness. So we will be discussing the Los Angeles abrasion test. Here you see the Los Angeles abrasion test setup. Here there is a rotating drum, and in this drum we put our sample along with the charge. What is meaning the charge here? These are the steel balls, and steel balls are put along with the aggregate. Then this drum is rotated. So these balls will be causing the wearing of the aggregate, and then we will measure that what is the wearing of the aggregates done in this test. The test method combines the attrition and abrasion effect both. The test sample of clean aggregate is taken in a standard manner as specified in IS code IS 2386 part 4 1963, and after that dried in oven at 105 to 110 degrees centigrade. It is placed in Los Angeles abrasion test machine along with specified abrasive charge. As I told you, what is this abrasive charge? These are steel balls. They are put along with the sample in the Los Angeles abrasion test machine. The abrasive charge is in the form of cast iron spheres or balls or steel spheres. Each sphere is of approximately 48 mm in diameter and 390 to 445 grams in weight. So these balls or the spheres are put along with aggregate in the machine. The aggregates together with the abrasive charge are rotated in the machine at a rate of 20 to 33 revolutions per minute. This is the rate of revolution. This is also important. And for 500 to 1000 revolutions are made. This depends on the grading of the aggregate, that how much revolutions are to be done. After completing the specified revolutions, the aggregate is taken out and now it is sieved through 1.7 mm sieve. The weight of the aggregate coarser than 1.7 mm is taken after washing and drying in a standard manner, which is known as the final weight. Now the aggregate abrasion value will be calculated by the formula original weight minus final weight divided by original weight into 100. This will give us the aggregate abrasion value. The limiting value of abrasion value for concrete aggregate is 16% as specified in the code, that it should not be more than 16%. Now let us move to the next test, which is aggregate impact value. Resistance of aggregate to sudden shock or impact is known as toughness of the aggregate. So this toughness of aggregate is also very important property because our structures are also exposed to the impact load also. So from that point of view, this property is very important. That is the purpose why we measure the aggregate impact value. Aggregate impact value is a relative measure of toughness of the aggregate. To determine the aggregate crushing value, a sample of aggregate passing through 12.5 mm and retain on 10 mm is taken. This sample of aggregate is dried for 4 hours in oven at 100 to 100 degrees centigrade. The dried sample is cooled and filled in cylindrical container in 3 layers, and each layer will be tamped 25 times with the tamping rod. Now the weight of the sample will be taken. Let us take that the weight of the sample is A. This aggregate sample is placed in the impact load machine, in which the impact load is applied through 15 blows of standard hammer falling from a height of 380 mm. 380 mm is the height from which we are allowing the hammer to fall on the sample, and such falls will be 15 falls, basically 15 blows. Now the aggregate is then taken out and sieved through 2.36 mm sieve. The weight of the fraction passing through 2.36 mm is taken. Let this weight, which is passing through the 2.36 mm sieve, is B. So we have now two weights, weight A, the weight of the sample, and weight B, which is the fraction passing through the 2.36 mm sieve. Now aggregate impact value can be calculated here as AIV equal to B by A into 100, where you know that A is weight of prepared aggregate sample and B is weight of aggregate passing through 2.36 mm after applying the load. So this way you can calculate the aggregate impact value of the aggregate. This aggregate impact value should not be more than 45% for the concrete used for the purpose other than wearing surfaces, and aggregate impact value should be limited to 30% for the concrete used for wearing surface such as roads, runways and airfield pavements. So here you see the impact load machine. In this impact load machine there is hammer, which you see an across equipment, and this hammer basically this is lifted and then dropped. So this is done 15 times and this height of drop is here 380 mm as I told you earlier. So this load is dropped from this height of 380 mm 15 times on the sample, and this load is giving impact on the sample. So this will be giving impact, and the effect of impact will be crushing of some sample, breaking of some sample. Then we take it out, we take the sample out and do the sieving and find the impact value as I told you. So that way we do the impact value test. Now after doing all these tests, let us see what are the effect of aggregate properties on strength of concrete. So as you know, aggregate is one of the most important ingredient of concrete. So its properties will be having effect on the strength of concrete. So let us see what properties may affect the strength of concrete. The properties are effect of size of aggregate, the effect of shape and texture of aggregate, then effect of soundness of aggregate. So these three properties are important. Let us see first the effect of size of aggregate. How the size of aggregate affect the strength of the concrete. So the size of aggregate does not affect much the strength of the low strength concrete. Means if we are considering the case of the low strength concrete, then in this case the size of aggregate will not affect much the strength of the concrete. But if we take the case of high strength concrete, the strength increases with decrease in size of the aggregate. So this is the difference between the low strength concrete and the high strength concrete. That in high strength concrete the size matters here, and as the size decreases, the strength of concrete increases. Why it happens? This is due to the fact that in high strength concrete the failure is more likely to take place due to the loss of bond between the aggregate and the cement paste. Whereas in case of low strength concrete, the failure of cement paste itself takes place. As you saw there, in high strength concrete, the failure of bond between the aggregate and the cement paste, that fails. But in case of low strength concrete, cement paste itself fails. The bond strength between the aggregate and cement paste depends upon the surface area provided by the aggregate. The surface area provided by the aggregates will be large for smaller size aggregates as compared to the large size aggregate. Because you know that finer the aggregate, more the surface area. So because of that, the smaller size aggregates will be having more surface area in comparison to the large size aggregate. Now let us see the effect of shape and texture of the aggregate on the strength of concrete. Now, there are different sizes, shapes of the aggregate. Here we are considering the shape and the texture. So shape also differ. There are rounded aggregates, angular aggregates, as you know, flaky aggregates, elongated aggregates. There are different type of aggregates as far as the shape is concerned. So let us see how these different shapes affect the strength of concrete. If we take the case of angular aggregate, then angular aggregate and aggregate with rough surface. So when we are talking the rough surface, means we are talking about the texture. Angular aggregate means we are talking about the shape of the aggregate. So angular aggregates and aggregates with rough surface provides better bond due to more surface area, hence gives better strength to the concrete. So you know that the aggregates which are having the rough surface as well as which are of angular shape, they give us the better bond, and better bond means better strength of the concrete. But if you take the case of flaky and the elongated aggregates, then these aggregates are weak in strength. Hence, they provide the weak concrete. They also provide the weaker bond. Their presence always lead to the poor strength of the concrete. Means if more flaky and elongated aggregates are there, then we will get the poor strength of concrete. Now let us see the effect of soundness of aggregate. As you know that weak and the porous aggregate containing any undesirable extraneous matter, this makes the aggregate unsound. Means what is the reason of unsoundness of the aggregate? Means the aggregate which are weak, porous and are having some undesirable extraneous matter, then the aggregate will be unsound aggregate. And the unsound aggregates reduce the strength of concrete, particularly under the moderate or severe exposure conditions, because the effect depends upon the exposure conditions also. So in case of moderate or the severe exposure conditions like variation in temperature, freezing and thawing condition, alternate wetting and drying condition, if these conditions are there, then if we are using the unsound aggregate, then certainly this will lead to the reduction of the strength of the concrete. So this way we discuss the different mechanical properties of the aggregates, under which we discuss about aggregate crushing value, how it is determined, what should be the range for a good aggregate, then 10% fine value, how it is determined, what is the range, then aggregate abrasion value and aggregate impact value. So these were the mechanical properties which we discussed here in this lecture. We discussed the effect of aggregate properties on the strength of concrete also, and in this the properties that we covered were size of aggregate, shape and texture of aggregate, and soundness of aggregate. So these all properties we discussed and the effect of these properties on the strength of concrete. So in this module we have discussed the all content in 3 lectures on aggregates, in which we discussed about importance of aggregate for concrete, then classification of aggregates on the basis of their source, shape, size and unit weight. Then the important parameters we discussed which are associated with the aggregates, such as bulk density, apparent specific gravity, water absorption and normal range of these parameters. Then we discussed importance of various properties of aggregates, means physical as well as the mechanical properties, and importance of these parameters on the performance and the quality of concrete. Then we discussed test procedures to determine the properties of aggregate. Then we discussed importance of sieve analysis and that of the associated terms such as fineness modulus, grading curve, sand zones, etc. Then we discussed effect of various properties of aggregate on strength of concrete. So this whole content we have covered in these 3 lectures. So I hope you must have understood the things in total clarity. So go through these lectures and try to grasp the things we have covered in these lectures. Thanks for watching.